Okay. Connor, could you finish this one, please? Log base b of mn, what does that equal?
um, log b of m plus log sub b of m.
Nice, thank you. Although they are subscripts, we normally say log
Really?
base b. Like, imagine like if you have an exponent, the a is the base of the exponent. Same thing because they're related to one another. Can you give us one more property aside from that?
Um, how,
Okay. How should I start that?
um, log base b of m to the p power
Okay.
equals p times log, um, base b of m.
Are you good with that, everybody? Thank you. Nicely done. Isabella, what's another one? The exponent? Well, how can I write it? I don't need the name. What should I write? Well, I'm not looking for any particular order, but oh, you were thinking about this one, this next one. Another one. Oh, yeah, could you remind us what that one is? And what base are you using here? Does it have to be base 10? Or ln? Could it be another base? As long as it's a acceptable base. Nice, thank you. I want one more. Kieran, what's another thing?
Log base b um m over
Of m over n? Okay.
that equals log base b m minus log base b.
Log base, wait, I'm sorry, log base bm, is that what you said?
No, log base b of m
Oh, okay.
or minus log base b of m.
Are we good? Were there any others you need to know? Yes.
Maybe what you should.
Oh, okay, so that's kind of like using this one, isn't it? Okay, so that's an example of when you would use it. Exactly. Good. Any other properties that people remembered? These are kind of the main ones, but there are some other things. You have an idea?
Um, uh, there's two inverse rules.
Okay.
First one is b the power of log base b of x.
Ooh, nice.
So that's just x.
Are we good with that? And this sets up, we have a logarithm inside an exponential, and because they're inverses, the log and exponential can't speak that x. Thanks. Anything else? So here's a log and an exponent. You could imagine an exponent and a log, right? So we could start with log base b of b to the x, and that would also equal x. Anything else? Here's some simple ones you should know. Kind of log base b of b equals 1, and another one log base b of 1 equals 0, and hopefully that makes sense. From that, kind of, right, these are just things you know about logs. You can imagine the log I'm about to put up there. It's definitely going through the point 1, 0, and the point b comma 1. That's where this one comes from. Right? That's this, and this, that's this. Then here's another one. You know I want 3 points on it anytime you graph log. Just kind of getting these logarithmic juices flowing. Between which two consecutive integers does log base 3 of 100 lie? Please show me between which two integers. I'm seeing 4s and 5. Keep the one up that it's closer to. 4. Yay. So how do we do this on a calculator? Three different ways. Sure, we able to come up with any of these? But if you had a calculator, what would you do with it? I would do the log button at the base of 3. Can you put a base 3 with the log button? Yeah, like special like the special one. You had to find log base, so you can actually find it directly, and it's going to be like 4 point something. Okay, thank you. Feliciano, what's another way to put in your calculator?
ln of 100 of 100 over ln with
Could we do this? Isabella, what do you think? Will that work? Kind of what we were talking about earlier, isn't it? Yeah, perfect. Any others? Roland?
2 times log of a base 3 of 10.
Would that be another way to write the expression? Where'd that 2 come from? Nice, good catch. Good. And of course, log of 100 over log is equal to 2. Perfect. It is nice to have that perfect square breakdown to simplify things. Sweet. Ready for the lesson today? They were talking about solving equations. What kind of equations, you may ask? Exponential. Dun dun dun. Bam. Okay, these are all exponential equations. Notice, oh, that we're on page 35. Notice that the variable is in the exponent. That's why it's exponential equations. I think you could probably already solve A, can't you? I'm going to show you the way I'd like you to do this. Anytime you have an exponential equation like this, if you can make the bases match, please do so. I'm not going to change the 2. I'm going to change the 16 and rewrite it as 16 is 2 to the 4th power. And you see what to do next. Kind of ignore the 2 now, or by observation, we can see that 3x minus 8 equals 4, or x equals 4. So we always want this. We want to have the matching bases. Once you do by observation, you know that the exponents are equal. Very, very straightforward. And B, should we make them both powers of 9 or both powers of 27? I'm gonna go through this silently, and if you'd like to try it on your own, just check with me when you are done or start. Good to go. Continue. Yeah, 4 more. So I want to have it.
Common base. If x equals 1 minus.
Need the last 27 minutes to pass, by the way, for the quiz. 27 minutes.
precisely. Because the quiz is, how long is it? It's 27 minutes. 18. Did you get C? Just check in with your neighbor, make sure things are going okay. You have people in front of you and or behind you.
Oh, wait, I'm just gonna be. You do it to negative two. No, just, no, 1/6. Yeah, yeah, it's -4, or whatever. No, it's just 1/62. Yeah, yeah. One over 60. No, bro, do you understand? I said I'm changing the 1/62 to 4. Okay, okay, but you can't change it about. 1/16. I'm not gonna use it. I'm sorry.
Just do your thing. You guys are fine.
Oh.
We're about ready? Give me another minute. Okay, ready or not? I just want to hear your ideas for this one for C. If you haven't finished everything, that's fine. Lucas, could you tell us what you did for this problem, please?
Well, I kept the base, solid base before.
Okay.
So the 1/16, I made that into, 4 to the speed.
Is this true that 1/16 equals 4 to negative second power? Okay, cool. So we have this. And then 4 to negative second power to the x plus 1.
Yeah, then I distribute the two on the right.
Okay. Did you do that like
-2x.
like the, okay, good.
Then you get rid of the fours,
Nice.
and then from there I got,
You could just tell us the answer that you got from there.
-7.
Do we agree?
Yeah, that's what I thought.
So you got, okay. I got a 3-point. That's 3 people agreeing, so oh, we got like 7 people agreeing. Yeah, yes, sir.
So. One of this is gonna buy. -1/2.
Multiply it by -1/2 or raise it to -1/2? Okay. Good question. And let's talk exactly about what we're supposed to do. Like we need either right to match the left or left to match the right. So what I see when I'm doing this is that 16 is simply 4 squared, isn't it? And then 1 over 4 squared is the same thing as 4 to negative second power. Now, I think if I were to manipulate this, I think if now I raise this to negative second power, negative 1/2, did you say? Or negative 1/2?
Yeah.
If I raise it to negative 1/2, I actually change that number. This would be equal to 16 to the 1/2, which would equal 4. But this number is not, right, that is 4. So we have to change it from the form that's in and rewrite it. Right, so I recommend thinking, okay, 16 is 4 squared, and then this is the exact same thing as this. But you can see this, the concepts are all right there. Not quite what we're looking for. Any questions? Now, if you really wanted to, you could rewrite this as a 1/16 to the something. But that's kind of too hard, isn't it? And the answer there is actually 16 to the 1/16 to the, that's the negative 1/2. So if you replace this side with 16 to the 1/16 to the negative 1/2, it would have worked. But too hard, right? Too much thinking. So start with integers and have them grow. Okay, this one, I need some help from Roland. Nice. Are we okay with this, guys? And I think you bypassed what I did on the left. Are you directly to 7 2x minus 4? Okay, that's great.
And then there's a QX negative 4 equals 4 next, and then QX equals 11.2.
And then x equals 11 over 4, you said? Are we good? Um, oh, that's my bad. That should be 3 over 2, shouldn't it? Thank you. I think it's a 3 over 2. I just messed up. Any questions? Isn't it a little bit of a pain to do 4 plus 3/2? A little bit of a pain. But don't forget that you could, and Connor, I'll get your question in just a second. You could clear the denominators by multiplying both sides by. You can clear the denominator by multiplying both sides by 2, right? So you can make this 4x minus 8 equals 3. And you can see it's just a little bit cleaner if you want to avoid a fraction. You did great. Nothing wrong with the other way, but it's an option for you. Connor, you had a question?
I actually figured it out.
Oh, nice. I like when that happens. E has e's in it. Was this one easy? Yeah, I don't know why this is next. It seems like kind of a step back in terms of rigor. If x minus 1 equals negative 2x. I'm going to move the 2 over, so I have 3x equals 1 and x equals 1/3. Does that match yours? For F, who can help me with this one? Oh, yes? Oh, good. Oh, did you get here? What did you do? Mhm.
So I'm going to I raised the power of the G to the power of X on 2.
Oh, I see. So you tried to make this the same.
Yeah. I still got 1/3.
I'd like to take a look at exactly what you did in a little bit. I'm going to just say, since we already have a base of E, we have base of E over there, let's keep it base of E. But yeah, you could make it base of E squared. I wouldn't recommend it though. F, what do I do with those two exponents on the left? Add them. Can you help me through this one, please?
Those job experts. And then get rid of the E's.
Uh-huh.
I got 17 plus X squared is equal to 17X.
Okay.
Then I moved everything to one side. So I had,
That.
yeah, that. And then
Okay.
I factored it.
Thank you for not using quadratic formula. Okay, factored into X. Okay. So X equals 8, 4, 9. Thank you. Are we good with this? So there we go. Exponential equations. I hope you like them. All the smiles I'm seeing, that's a yes. Example 2. Did we start the chapter with these problems? You already know the answer for this, don't you? We check quickly, just ask your neighbor, how do you do this problem? It does say use logarithm, so you know you're going to rewrite this as a logarithm. Is that right? And that did it, didn't it? You're done. You get log base what? 4 of 15 equals x. So notice it's still an exponential equation, but it can't be done like the other ones. You can't write 15 as 4 to anything. You know that x is going to be a little bit less than 2 if you like use your calculator, but we can't actually use the last method. So when you can't make the bases the same, please, please, please use logarithms. Agreed? Yeah. If you can't make the bases the same, please use logarithms. So this is one way to do it, and that's the way I do recommend. I do want to show you one other way to use logarithms. It is as an operation. I'm going to take the log of both sides, specifically the common log of both sides. I'm just going to rewrite this as log of 4 to the x equals log of 15. And this is an equal sign here. Let's see if I can actually make it look like one. That's an x. Okay, but how will this help? Yeah, take a look at that left side. What can we do with that exponent? Let's see the gesture. Gesture is the sound effects are optional. Just take it off the exponent and you put it here in front. X times the log of 4 equals log of 15. But how do we solve for x? Check with your neighbor. How do you solve for x now? How doth we solve for x? Now, do you have an idea? Divide by what? Do we agree log of 4 is just a number? And it's being multiplied by the x? That's how it works. Let's divide both sides by log of 4. We get log of 15 over log of 4. Thanks, Maddie. Are we good with that? And does it make perfect sense that these are equivalent based on what you know? Right? Kind of nice. Right? So either way it works. You get a correct answer the same. Either way you go. Would you please try the new method for B, please? There are too many pleases in that sentence. We'll take the log of both sides. Okay, from here, we take the x and move it down, or we talk about what Feliciano was talking about earlier. Doesn't the base here match the base? So isn't the answer just x equals log of 120,000? Or we could bring that x down, then you know that the log of 10 hopefully is 1. Rowan.
Right, that is log, so plus
Oh, we could, but I'm just gonna leave it like this. Do you all see what he's saying though? Log 12 plus 4. That's a really nice extension. Ah, so pretty. Do you see it? All those zeros, it seems like a waste not to. All right, so we'll break that up into log 12 times 10,000. You seeing it? You seeing it? Are you feeling it? This is really nice. I'm gonna proceed because it doesn't make sense to stop halfway. There we go, log 12 plus 4. I would not expect you to do that on a test or quiz, but if you can and you have a little bit of time, why not? Extra credit? Highly unlikely. The extra fun. Example 3A. Step 1, add 3. Step 2, divide by 40. How do you want to solve it from here? You're rolling for 300?
so it then becomes log ln of six equals 0.6x.
Perfect.
And then you write that as 5/3 times ln of six equals that.
Do you see where that 5/3 came from? 0.6 is the same thing as 6/10 or 3/5, right? So to solve for that x, you could just multiply both sides by 5/3. That's nice. Good question. Yeah, go ahead and discuss this with your neighbor. Make sure that everything makes sense.
I do. I don't. Yeah, that's what we were. We're here.
Are we okay? Yeah, where did the ln come from? It just suddenly popped out of nowhere. Where'd that come from? What's that? Log base e. Well, this is exponential, and you know that you could take any exponential function and change it into logarithmic. So we could make this log base e of 6 equals 0.6x. And log base e, of course, is ln. All right, so that's where I imagine that's where it came from. And Lucas, can you tell me?
Is that like the same as ln of six to the farm would be?
Isn't that nice? And can you imagine multiple choice? What kind of fun a test maker could have with these? All the different forms. And of course, since it's to the 5/3, we could rewrite that as ln of the what root? The cube root of 6 to the 5th or something, right? We could play around with it so much. This is what I'd be looking for. Or ln of 6 over 0.6. Like if you just want to divide by 0.6, that'd be fine. At this point, I want you to just solve it, and I'm not too concerned about the form of your answer. But that was really nice. Thank you. Yeah. Yeah, thanks for everyone who participated in that. B. Can we make them both powers of 5? No. Can we make them both powers of 4? Only if you're a miracle worker. Instead, what we're going to do is use the other method. We're going to do what to both sides? We're going to take the log of both sides. What log base what? It's up to you. You could do ln, you could do log, you could do If you want to do log base 5 or log base 4, that'll work. Generally, we take the common log of both sides. Now, this one's pretty tricky. Let's see if we can get through this algebraically. What symbol do I need to see on the next step? Important symbol. Two of them, they come in pairs. Parentheses. You better put parentheses. Okay. So you got here, I'm sure. But what are you supposed to do now if you want to solve for x? We could divide by log 5. Yeah, I think we're gonna have to get those x's out of the parentheses, and we do that by distributing. Log of 5 and log of 4 is just numbers, so we distribute. X log of 5 minus 2 log of 5 equals 2x log of 4 plus 3 log of 4. You know what to do next? Yeah, how do you get the x's on one side? Beautiful. Are we good with that? I'll work silently while you do your best. Finish it. I'm gonna call on someone in just a couple of seconds, so make sure you have an idea of what to do. Okay, Jihan, you have an idea?
Um.
What's that?
Um, I put it in, but
Okay, well, from here, I've been guiding you to here, so hopefully you're here. Now notice we have how many terms on the left side? Is there a common factor in those terms?
Yeah.
What is it? They both have an x, don't they?
I should not. I got that.
Thank you, yes. Leaving us with,
Log 5
okay,
minus 2 log 4,
perfect.
and then in there you can just divide the whole thing in parentheses. And we get x equals 2 log 5 plus 3 log 4 over log 5 minus 2 log 4.
Woo! Thank you, Jihan. What do you guys think? Do you want to check? No, no, that's the last thing we want to do is something like this. But make sure to work carefully. And if so, you'll get at least most of the credit, even if there's a little bit of an error. Do we need to talk about any of this? Are we okay? Make sure we understand what happened. First thing is exponential with different bases. Take the log of both sides. Take those exponents down. Make sure to include parentheses. Then from there, after you have x's trapped in the parentheses, that's why we distribute. There are terms that have x, gentlemen. Group them on one side, factor out the x, done. Have one more problem to do together. How are you supposed to do this? Like, take the log of both sides? That seems wrong, doesn't it? Check to see if your neighbor has any idea about what you're supposed to do with this. I'll leave this in case you guys are still copying. Okay, what words am I hoping come to mind for this, for C? What are some words besides fun? Substitution, possibly. Factoring. Oh, nice. Right, it's three terms. We're probably going to be factoring. And also with that too, I want you to think about the word quadratic. Yes, I think I heard that over here. Nice, okay. I'm going to do this without substitution, but if you did substitute, I recommend that you say that u equals e to the e to x times 2. I'm just going to go ahead and factor. Does this make sense? E to the x and e to the x? And now I need to find two numbers that multiply to 3 and add to -4. I think I know them. Yes, 7 and -10. Just kidding. That didn't even work at all. And now, our three favorite letters. Z, P, P. E to the x minus 3 equals 0. E to the x minus 1 equals 0. We probably skip that. E to the x equals 3. And e to the x equals 1. How do I solve that first one? Is it? Is it? Really? I like to make you squirm. Is it ln? ln of what? Yeah, x equals ln of 3. Nice, thank you. And this one? It's just zeros, and you can tell by observation x equals 0. Or you could use logs. You get ln of e. ln of 1, excuse me. Okay. I think we have just enough time to do this. If 2 to the x equals 3, what does 4 to the negative x equal? Thank you. Yeah, this is a little bit of a trick. What I'm going to do is I'm going to rewrite this 4 to the negative x. So it's in terms of just 2 to the x. We know that 4 to the x is 2 to the 2x minus to -1. So 2 to the x to the -2. Did I do this right algebraically? Does that make sense? I'm just manipulating it because my goal is to get h to be that. Because 2 to the x equals 3. And 3 to the negative second power is 1/9. Dun dun dun. So it's not like we're solving for x. We're manipulating the other expression that we already know about x. we have a couple minutes before we take the quiz, so get mentally and physically ready.